I just wanted to make a quick video about how to use the graphing tool on MathXL for graphing exponential and logarithmic functions, because it works a little bit differently than the graphing tools for other types of functions. All right, so here we have, on this particular homework assignment, an exponential function, and we're being asked to graph it. So I'm going to go ahead and click here to begin the graphing process. The first thing you'll have to do is pick which shape you want to use. There's two here to choose from. There's the logarithm tool, and then there's the exponential tool. And so if you can mouse over those, that will help a lot for helping you make that decision. This is an exponential function, and so I will use the exponential tool. Now, the thing that's weird about this is you bring your cursor over here to start the graph, and it gives you crosshairs and lets you know where you're putting your point at, right? This is at -3, 25. It doesn't matter where you mark this first point. It's going to give you the basic exponential function graph. So don't waste your time trying to find a good point to graph for this function, because it doesn't matter where you click for this first point. So I'm just, to really illustrate that, I'm going to go way up here in the corner and I'm going to click over here, but look where the graph shows up. All right. It didn't care. It didn't care where I put that point. Now this particular tool set is a little weird. It gets a little more user-friendly when you actually have to use these tools, but these are slider bars for determining if the graph should get shifted to the left or to the right, up or down, flipping, check the box here. Like if I check the box here, it flips the graph over. But this is a basic exponential function. None of these things are occurring. There's no stretching or shrinking. There's no shifting. There's no reflecting. The only thing you have to change to get the right graph here is the base. By default, for whatever reason, they put here the base as E, as Euler's number. We just need to change it to 1/13. And when I click out of there, notice how it will adjust the graph for me. And I never have to actually plot any points. All I have to do is get the right base, input the right transformations, and that's how I get the right graph. So you do not get to interact with the graph directly. You don't get to plot points directly. You have to adjust the graph indirectly using this set of tools over here. All right, so now that I'm done, I'll go ahead and click off of that, click save, and check my answer, and we're good to go. So it's super easy. Like when people, like at first it's really confusing looking, but once you see how that goes, students are always amazed, like, wow, that was really easy. All you had to do is change the base. It does the rest of it for you, right? Now, you'll still have to answer for the domain and range and whether it's increasing or decreasing. And also be aware the asymptote here is on the x-axis still, which is at y=0. Let's look at one that's a little bit more challenging, that has a little bit more going on. Like, I don't know, let's see if I can find a better one than that. Oh, that's okay, I guess. Like maybe this one, I guess. So you'll have to first, before you get to the graphing part, you have to determine where these points are going to go when you apply these transformations. I'm going to try to do this as quickly as I can so I can get to the graphing part, because that's the point of the video. The two transformations that are happening here, the 2 here is going to shift the graph up 2, and the negative sign here is going to flip the graph over the x-axis. So I'll do the flip first, and then I will shift the graph up by 2. Both of those maneuvers only affect the y-coordinate. They do not affect the x-coordinate. So the x-coordinate for all these will just stay the same. So I'm going to start with this last point because that's usually the easier one to work with. So it's still going to be at 1 for the x-coordinate. But then the y-coordinate, when we flip it over, will change the sign. So it becomes -3. And then we're going to shift that up 2. So from -3 going up 2, I get back to -1. All right. So that's where that point's going to end up. Comma, start another point. We'll do the next easy point here, 0, 1. It'll still be at 0 for x because that coordinate is not being affected at all. But for the y coordinate, flip it over so it becomes -1 and then go up 2. So it goes back to +1. All right, so that's a weird one. It goes back where it started, but that's what ends up happening. For the last one, the x coordinate will still be -1. We're going to flip over the y-coordinate so it becomes -1/3 and then add 2 to that. And that's going to give me, if I'm thinking of this right, hopefully I am, 1 2/3. And I think you can type it like that. I think it'll be okay with that. Let's find out. All right, so check the answer. All right. And again, notice it didn't care what order I put the points in. It was in the reverse order, but that was fine. All right, so now for the graphing part, same thing as before. Click here to start. Click the exponential tool this time because it's an exponent. Doesn't matter where, so don't sit there and try to be like, okay, this point should be at 1, -1, because it's not going to care where you put this first point. Right? I could mark it here, but it's just going to give me the basic exponential graph. It's not going to plot the point that I actually mark. Right? So again, to really illustrate that, I'll click way up here in the corner. It doesn't care where I clicked, right? It put the basic exponential curve here with a base of e. So that's the first thing I'm going to change. The base shouldn't be e. The base in this case is 3, right? The base of this exponent is 3. Now it does matter the order you input these transformations in. So the correct order here would be to flip it over first. So let me just show you if you do it backwards, right? The 2 is shifting the graph up by 2. That's a vertical shift, right? Up and down is vertical, left and right is horizontal. If I put 2 first, notice how it changes the graph. It's going to make it go up by 2. And then I flip it over the x-axis. It's going to look like this, right? So notice it doesn't flip it over in place. It flips it over the entire x-axis, which is not the graph that we want. And notice how the vertical shift changed to -2, right? Because it flipped that shift over as well, right? So we don't want that to happen. Whoops, okay, didn't like that. So I guess I need to go back to 0 here, and then this. Okay, so the correct order to do this in is to flip it first, and then shift it up 2. All right, and notice how it goes there. So again, notice I'm not plotting any points. I'm not interacting directly with the graph. I can only change the graph through this panel right here, and that's the only way you're going to be able to adjust the graph. Once you've adjusted it, it should match the points that you have found, right? So 1, -1 is located right there. So now the graph has the points that it needs to have. 0, 1 is still on this graph. -1, 1 2/3, right? It's a little bit over 1, which is right here. So the points are now where, the graph exhibits the points that I found earlier. So that's a good way to double check that you have the right graph. Okay. So that's how the graphing tool works for exponential and logarithmic functions. So when you get to 4.2 and you're graphing logarithms, it'll be the same thing, except that you will be choosing, oops, I guess I can't go back, but you will be choosing the logarithm tool instead of the exponential tool, right? So if I go back to, let's see, is there one I could just access right away? I wanted to, maybe this one. Yeah, so the only difference will be in 4.2, you'll be picking the logarithm tool, but it's the same structure. You'll plot a point, but it doesn't matter where you put that point. It just gives you the basic logarithmic graph, and then you change that graph through the panel that it provides. All right. So if you have any questions or any difficulties with the graphing on exponential and logarithmic functions, please, if you're my student, contact me and I will help you further with that. But I hope this will give you an idea of how to do these graphs on the homework for MathXL.